Distinguished board members, I want to thank you for this opportunity to come up and give us talk about the website. My boss, Jose Franco, had intended to be here, and he was called back to Washington for some urgent business this week, which you may guess about a little bit about that. It's my pleasure to be here and represent him and the website. What I'm going to do this afternoon is give a little talk about some of the generic aspects of the web, some going back a few years, why the location was found, the mission of the Carlsbad field office, touch a little bit about the transportation system, talk about safety accolades from the facility as it related to DOE, then touch on the disposal, shipments, and summary, and hopefully address some of the questions that I understand you've asked Mr. Bishop. Finish off with some priorities of our true-way shipments throughout the complex, throughout the nation, and then finish off with a regulatory slide on some of the regulatory interfaces and accolades we've had related to the state of New Mexico, the Environmental Protection Agency, and our relationship with the land side. So with that, we'll get the first slide, please. I'm going to take you back a few years. This is a picture or an illustration of the United States. And illustrated here are two items. One is the areas that are underlain by bedded salt, and the areas that are underlain with salt zones and anticlines. For reference, here's New Mexico. This is the Permian age, which is about 250 million years old. Salt beds. Back in the middle 50s, they were looking at geologic disposal. That progressed to about the 1970s. In 1971, they were looking at a site in Lyons, Kansas, because it had these favorable geologic characteristics. That focus then changed in the early 70s to southeast New Mexico, right in here. And the favorable geologic characteristics they were looking for were kind of listed over here to the right, is that they had a host rock or a geology that would behave plastically. That core would, if you excavated it and opened it up, it would close in and encapsulate the buried waste, therefore removing it from the biosphere. The other geologic characteristic is a stable geology. Low seismic activity, the lack of volcanism, so that they would have a stable geology as you're replacing waste and for the future, because the regulatory time frame for the WIPP site is 10,000 years. The other characteristic is the lack of water, or at least the ability to predict water and have it for minimal fresh water for ground use. And also so you don't have dissolution of the host rock and the waste in the future. And the last item, which is really unique from a mining perspective, is that the host rock is easy to monitor. All of those characteristics were looked at to identify the location for deep geologic disposal for transuranic waste. And the site selection committee worked through this and decided southeast New Mexico, the WIPP site. However, that's just the first part of selection. The other thing that's related to that is the ability to design, construct, and operate a nuclear facility in a very safe and compliant manner, given the favorable characteristics of geology. So I kind of progressed here from 1970s to now. A few years are missing, kind of like geologic time. But so let me take a look at where we're at now and the mission of the Carlsbad field office and the responsibilities we have for operating this facility. Carlsbad field office, Department of Energy, we're underneath environmental management. The environmental management mission is to ensure that there's safe removal of legacy waste that's left from 5 decades of the production of nuclear weapons. Our office is a single mission office, which is to provide safe, compliant, and efficient characterization, transportation, and disposal of defense true waste. And I'll be referring back to these, what I would call the 3 legs on a stool, the characterization, transportation, and disposal elements, which are the resources and, if you will, the building blocks of how we are able to function and provide service to the nation. So that's our Carlsbad field office. We can't do it alone. Next slide, please. This is an illustration of the composition of what we call the WIPP team. Department of Energy. We have a management and operating contractor nuclear waste partnership that's responsible for managing the WIPP facility, which is an underground repository. In addition, they provide the logistics for transportation, packages, and a central characterization project, which is one of the key elements when we facilitate many of the sites, particularly the lab site here in New Mexico. We have 2 national laboratories who are housed in Carlsbad, a Los Alamos group, which are the scientific advisor for waste characterization, as well as some of the academic chemistry effort that goes on as part of our certification basis. Sandia National Laboratories is the scientific advisor for repository certification which is predominantly focused on the Environmental Protection Agency regulations. Technical assistance contractor who supports CBFO, which is the Carl Van Field Office, for conducting audits. One of our big programs is annually going to the sites and ensuring they're compliant with the requirements, regulations, and quality assurance. So we're an auditing agency as well. So we go to those sites, perform those audits. We also have the regulators attend those audits and make sure that we're doing the job with generator sites. It's a very intense and very robust program. We also have to monitor the transportation equipment. We have a satellite tracking that monitors all of the transportation, our trucks that basically all the ways across the country. With that, we have two transportation carriers, Visionary and CAPS, which are the transportation carriers for transporting the waste, both sending empties up to the site as well as bringing the loaded packages back to the facility for final disposal. So that's the team that works together. This is really our onset, but we have to work with all of the sites, in addition work with our counterparts at headquarters, regulatory agencies, distinguished folks like yourself, the Citizens Advisory Board, and many entities like that. So what I'd like to talk about next, I think, is the types of waste. Next slide. There are two types of transuranic waste, which are, the acronym here is TRUE, contact handled and remote handled waste. Now, the definition and the enabling legislation for the website is the Public Law 102-579, which is the Land Withdrawal Act, which basically defines the types of waste, it defines transuranic waste, it defines many things, the regulatory requirements we have to meet, it defines a capacity. Congress actually placed a limit on the transuranic waste that we can receive it with. And that number is 6.2 million cubic feet, which is about 176,000 cubic meters. And that's the limit, that's the capacity of the Land Withdrawal Act. They established the land withdrawal area, they established regulatory, many things like that. Contact handled waste, I'll talk about the picture in just a second. But the reason I wanted to mention that value of 176,000 cubic meters is this says 96% of the waste to be disposed at WIPP. The other type of waste is remote handled waste, which needs additional shielding and distance to be able to handle that. The Land Withdrawal Act does not limit the volume of remote handled waste. That actually comes from a consultation and cooperation agreement with the state of New Mexico and the Department of Energy that started way back in the early 80s. And that value is 7,080 cubic meters of remote handled waste. That got, if you will, put into the authorization based document for WIPP in our record of decision. So if you take 7,080 divided by 176,000 cubic meters, the CH waste comes out about 96%, and remote handle comes out about 4%. Now that's how we can divide it up. But the Land Withdrawal Act is generic for transuranic waste. So that's kind of an important point as we go forward, maybe to help address some of your questions. On the right here is a picture of an underground disposal room. The disposal room is located in salt about 2,150 feet below the land surface. The nominal dimensions is from the floor up to the roof, or the ceiling is about 13 feet. From rib to rib, or from wall to wall, it's about 33 feet. And then the lintel is 300 foot long. What you see here is contact handled waste that is in place on the floor. Some of you may have been to the repository, seen it, others of you, hopefully you get an opportunity to go in October, you get a chance to see this. It's in place on the floor in the underground, and we stack the containers up to 3 high. Not in all cases, it depends on the containers. What you see in here is a standard waste box stacked 3 high. This is a 10-drum overpack. On top of these black drums are 100-gallon drums in a 3-pack. We also have at the very bottom here our 55-gallon drums which come in a 7-pack. All of those columns are overlaid with a magnesium oxide, which is an assurance requirement as part of the EPA regulations. And the MGOs there, so whenever we back out of the room, the roof comes in, it encapsulated, it creeps closed, it breaks those bags, and magnesium oxide encapsulates the waste. So in the future, if there's airborne intrusion or water comes in, magnesium oxide is basically a pH buffer, like milk magnesia, and it helps keep this where the actinides may be at their lowest solubility. That's the intent of the magnesium oxide for regulatory requirements.
George?
Yes?
Compared to Carl's web cabins, how deep is WIPP
WIPP is 2,150 feet below the surface, and Carlsbad Cavern is much shallower than that. But from an elevation perspective, the Carlsbad is a little bit higher in elevation. So there are different geologic horizons and at different vertical, horizontal distances. So WIPP is much deeper than the Carlsbad Caverns and geographically separated approximately 35 to 40 miles. Thank you. Contact handled waste, we started disposing of waste in March 1999, and the first site to ship us waste was Los Alamos National Laboratory, the first shipment. So accolades to them for doing it. Yes, sir.
In the contact handled waste is plutonium-239 contact handled waste.
Yes, sir. The contact handled waste is based on the surface dose rate on the outside of the container. The remote handle typically has more cesium, strontium, and cobalt, which is a higher gamma emitter, which I'm sure you're aware of, for the remote handled waste. You can have 239 in contact handled and in remote handled.
Okay, and does americium make it more or less of a contact handled waste?
It depends on the concentration and the location with the drum when they do the surface measurement. The contact handle is basically a definition in the Latin drawback. It's the surface dose measurement on the outside of the container. And that's how the generator sites make that determination based on the dose measurement. And the radionuclide, the isotopes you mentioned, do drive that depending on their concentration and their configuration within that drum. Next slide, please. The other type of waste is remote handled waste. And that represents about 4% of the waste that can be disposed of given the varying legislation and the regulations at the WIPP. What you see here on the right is a disposal room. And the sequence of the placement of the transuranic waste at WIPP is we will excavate a disposal room, actually 7 disposal rooms in a channel. This is the disposal room here in salt. If you look up on the top of this figure, there's some rock bolts. Once again, this is the geology that closes in. So as soon as we excavate this begins closing in at about 3 to 6 inches a year. So we put rock bolts up here to hold it, basically slow it down so that as we replace waste, we're moving out of that area and it can come down naturally and do what the purpose of that is to encapsulate the waste. This piece of equipment is called the horizontal placement and retrieval equipment. So what we do is we excavate the area, open the disposal room, go in and drill boreholes on the ribs or the wall. And those boreholes are 30 inches in diameter, about 4 foot tall, and about 17 feet deep. Now, remote handle comes to us in canisters that are nominally about 10 feet long and 29 inches in diameter. This requires shielding. A lot of this equipment, if you've had a chance to tour WIPP, and if you don't know, put another plug, when you get to tour it, it's much easier to talk about and show when we're standing close to it about this equipment and what the purpose of it is and how it functions. But this is a transfer mechanism. In this area here, we have a facility cast that's shielded. It's rated for 7,000 R. It's got about 3 inches of lead and an inch of steel around it. It's placed here, and this piston basically opens, there's shield doors that open, comes in contact with the canister and shoves it into the salt. The salt is basically a natural shielding component, as well as it helps encapsulate it and remove it from the CH side of the house. So we'll drill these boreholes along the ribs. If you look back here, you kind of got a real good picture. There's an enclosed canister, which is about 10 foot long. Then we put a shield plug, a cement shield plug in front of that to help reduce the amount of toxic scattering that we could come over that to make sure we protect the workers. Once RH is in place in a room, we'll move to the next room and begin to place the CH. And that's sort of the sequence of how it works. We drill the boreholes, put in the RH, go to the next room, put in the CH, and continue to move outward from panels from disposal room 7 out to 1. I got a figure a little bit here that will give you a little bit better explanation, a diagram to explain that sequence and how it works. I would note here that the disposal of remote handled waste started in January of 2007. That came much later in the time frames for us. So, next slide, please. Here's an illustration of 3 dimensions of the WIPP site. The surface facilities, 4 vertical shafts that go to the underground, And this is the plan view of the underground. The disposal area is composed of disposal rooms. Oops, I think I just ran out of labor. You have an extra one, or?
I have batteries.
I don't want to step in front of the slide here too much, but excuse me just a second. Maybe I'll step to this side and talk a little bit about the location. We have disposal panels, 1, 2, 3, 4, 5, 6, 7, 8, that are the disposal panels for replacing the waste. Oh, excuse me. Thank you very much. Appreciate it. Oh boy, you're going to trust me with the lasers here. Oh, red one. Really? Thank you very much. There are panels, and each disposal panel has 7 disposal rooms. 7 in the back, 6, 5, 4, 3, 2, and 1. And each disposal room is 13 feet tall, 33 feet wide, 300 feet long. So we go in and we mine the panel, mine them out, have 8 equivalent panels. The original plans for WIPP were actually started in mid to late 80s. WIPP was actually ready for operations in 1988. And at that time, the early planning was based on an estimate of inventory. So they established an estimate of the plan of 10 equivalent panels. So there's 4 on one side, 5 on the other, and then these tunnels, or the drifts in between, this would be equivalent panel 9, and this would be equivalent panel 10. So the planning was for 10 equivalent panels. That's in our permit, that's in our APA certification, that's in our authorization basis. Well, that was the planning, and I say that very important. The depth here is 2,150 feet below the land surface. We have 4 shafts that access that. We have an air intake shaft where we pull air into the underground. We have a salt handling shaft because we're always mining. We bring salt up to the surface. We also can take personnel and materials down. We have a dedicated waste shaft. That's the shaft that brings the waste down to the underground replacement. We can also use that for materials and for personnel. However, we don't have waste. At the same time, we have personnel and materials. And we have an exhaust shaft. So the way that this works is they bring air in from the surface, pull it through the facility. We have bulkheads so we can regulate, so we can do construction, we can do waste disposal and exhaust. And then we exhaust it out the exhaust shaft. So we're pulling air through the repository, controlling it, and be able to work. That's how we ventilate the underground. We're under the Mine Safety Health Administration, so we have to follow that as well, which is kind of unique for a DOE facility. That gives you kind of a feel for the underground, what it looks like. If you've been there, you go there, we'll have an opportunity to tour you and show you at least where we're at, how the disposal room looks prior to being in place, and what it looks like with excavation in there as well.
Did you say which shaft is which with the laser pointer?
Yes,
and
ma'am.
why it's placed where it is?
Yes, ma'am. The air intake shaft is the one on the left. And the way this comes down here is it's able to ventilate the north area and ventilate the southern area so we can control the splits from a construction circuit on the north and the south. So we pull most of our air down there. The salt shaft is located here. And the reason it's located at that location is, yes, sir.
Well, go ahead and answer Allison's question, then I can ask my question.
Okay. The salt shaft is located in this area here. Facilitate the tunnels is this main drift we use here is where we bring our salt out primarily. That's the construction circuit where we're mining to bring the salt out and bring it to the surface. The waste circuit or shaft is this one here. Excuse my wobbly, too much coffee. I'm getting up at 4:30 this morning. This is the waste pathway, which is right here, where all the waste goes and goes to the roof. So that shaft, to control the ventilation, is a downward at the back of the transporter and out the exhaust. So you never have it going back up that way. So that's why that waste shaft is located there, and the underground is configured. The exhaust shaft is here to the right. So all of the air comes in here, is distributed, goes out to this drift, and goes out the surface. And we control those by bulkheads or the equivalent of doors to be able to regulate that. And those shafts and the underground are designed for this design to maximize the ventilation and from safety perspective to always keep the ventilation at the backs of the workers, so if there's ever an accident, it goes past them and out through the exhaust shaft and reduces the potential for workers' problems. Yes, sir?
Why the odd configuration on the disposal rooms, 13, 33, 300?
So that's a very good question. In the early design, back to the early 80s, they looked at rock salt behavior. There was some, I showed you that map of the dome salt. There was some experience in dome salt, which is different. It's a dome versus bedded salt. When they went in and looked at the information of what was the optimal configuration from a room to keep the waste in there so they could have enough time to replace it before it closed in on itself, that's the dimension that they identified. And the good news is that's a pretty good dimensions because it works very well with us. We mine a panel, which is 7 rooms, in about 30 months. The way the shipments come in, we close them in about 24 to 30 months. And that's just about the right timing. As long as we have the waste available, we have the right amount of funding to be able to facilitate that design. So it's a pretty good design. It doesn't work. As we've gone to the south and do more mining and replacement, we recognize there could be some optimal changes in that. And that's the thing that we'll talk about in the future is if we go back and utilize WIPP to its fullest, we may propose changes to that configuration to optimize that based on our knowledge of the geology we've gained over the past 20 years from the original design. Question. Yes, sir.
George, what do you monitor in the shafts for gases? What kind of gases do you monitor? And
From the Mine Safety Health Administration, we've got to go in and do a check every morning to make sure that we have oxygen. We also look for methane. We look for SO2. We're a non-gassy mine, so we don't have problems with methane or sulfur. So we do that from a mine safety to make sure we have an optimal oxygen. We operate diesel equipment, so we've got to have the right amount of airflow for individual pieces of diesel equipment. From a regulatory perspective, we have to monitor from a permit for volatile organic compounds. For example, some of the waste that we got from Idaho that came from Rocky Flat has carbon tep. Carbon tep was a degreaser used to clean parks and other stuff, and it's in some of the oasis sludge. That gets in drums, it gets placed in there, and you have those emissions. So we have to monitor that. We actually have a monitoring program to look at the 9 or 10 top hazard chemical constituents that we monitor. We monitor at each individual room when we're replacing it, and then we monitor outside before it goes to the exhaust shaft to make sure we don't create toxic environment on the surface or in the underground.
So reminding you, as you guys look at Area G, my side of the house, we're required to put vents in all our waste containers, and reminding the board, that when we have plutonium waste, true waste, we have the potential for hydrogen generation in a drum. So all these containers have to be ventilated for hydrogen. So that's why they have to look for these other gases coming off. We want to make sure there's not a buildup of hydrogen in any of these containers. They're all ventilated, so they have to look for organic compounds that might be released through that ventilation system as well. And George, it might be helpful to kind of match up your photograph with those waste hoists to your diagram there. On your photo below, you have the 2 shaft hoists.
Oh, correct. That's a good idea. This is the air intake shaft. It's a shaft here. Salt hoist. Middle one. The waste hoist is encapsulated in case there's a potential accident. It's underneath negative pressure. So if there's waste hoist, it stays within containment of the building. And you really can't see, but the exhaust shaft is on the other side, and we have fans that can pull it through. Thank you, Lee. I always forget about the WIPP picture in the bottom.
It's just a good matchup to your diagram.
Thank you very much. Yes, sir.
On your intake shaft, is there, I would imagine there's some means to contain or to address the particulate, especially like, say, spring winds. Have there been any times that the facility has shut down because of that?
Those are not from the underground facility.
Okay.
We bring in, we ventilate with about 460,000 cubic feet per minute of air. It's a large volume. It's a relatively small area. It's 3,650 feet from there. So it's about a mile in the underground. That's a lot of air for that area. We have not had to shut it down due to dust storms or other areas, or other reasons like that. So, good question. But we do bring in dust. You bring in hornets from the air, you suck it down in the underground. It's obviously a hornet down there, or a wasp. So, next slide.
Judge,
Yes, sir.
so how do you monitor and control explosive gases after you seal them?
Good question. Actually, we don't seal a room. Each disposal room is closed. We put up a ventilation barrier, and that ventilation barrier is currently a grass cloth or a bulkhead that deflects that from each disposal room. As soon as you put that up, the room typically goes anoxy, relatively quickly, lack of oxygen there. Based on the drum beds, we don't have that buildup of explosive gases. Every drum or container has a vent in there. The biggest concern is the radiolysis producing hydrogen. Since they're vented, you get emanations, emissions out of that. Once we close the panel, the early thought was that you could have a methane buildup from methanogenesis, from microbial dealing with waste, and you could get a deflagration, which is not an explosion, but it's a spark that creates that. In our panel closures, original design was a 12-foot block wall to protect, a monolith to protect the workers. What we found out, we monitored in panels 3 and 4, the hydrogen and methane buildup, and we found that we do not get the generation of hydrogen and methane from what we call juicy waste, which is a high organic waste, that would get a very large environment of hydrogen and methane, which relate to an explosion. So we don't see that happening. If we were to take all the gas generation rate and maximize it and do a conservative chart and graphic, it would take approximately 20 years to get that buildup. If everything continued to generate gas at the same rate, which it does not happen. So we would close the panel in about 2.5 years and put that closure. So that's a conservative approach if we were to get that. We don't believe that from a monitoring that we would get an explosive environment in a disposal room or in a tap. So that's what our data shows us. Good question. Yes, sir.
What kind of seismic activity do you have?
Around the area, there's a couple of major old Permian faults and some modern day faults that are many miles away. Some of the oil and gas throughout it will have a little bit of seismic activity as they're extracting gas. We'll have some movements. One of the real neat things about WIPP is that it's made out of salt. So it's plastic, so it doesn't deform like you have a break in a rupture. It tends to bend and go with the wave. So we've had some earthquakes from magnitude 4 or 5 relatively close within, was up by Hope, so that's about 75 miles. That was the epicenter. We saw nothing at WIPP. We recognized it with some of our meters, but what we have to do is, because of the shaft and the steel, we go in and do an inspection of the shaft and make sure that it's aligned steel, because that's the more brittle, more rigid. But the salt tends to absorb those waves and doesn't impact it at all. And it's a very low seismic area.
There seems to be some concern that if mercury is stored above ground around it, that the seismic activity might impact that decision. What's the
You're going to have to speculate here a little bit. So. There's been no decision on the mercury VIS. Yeah, hopefully you're aware it's a draft. There's been no final decision. They looked at 3 sites around WIPP for the surface storage. If that was to come to place, they would have to do a seismic study and evaluate what kind of construction you need to construct to try and ensure you don't have a seismically environment that could create a release or loss containment of that elemental mercury. But one of the reasons WIPP was chosen is because of the low seismic activity there, very specifically, and the recurrence interval is very low. So I don't know what the final decision on the mercury is, and really can't speculate, but seismically, WIPP is very stable.
So a lot of you know I'm a former Yucca Mountain employee. We had a couple seismic events at Yucca Mountain, and what we observed there in underground was that it's much like being in the surf and ocean. If you're at the surface, the wave hits you and you have a lot of impact. The farther you are below the wave in the water or underground, the less impact you found. In fact, we had a pretty good seismic event near Yucca Mountain, and there was absolutely no damage in our underground. So it's kind of a unique situation with the mining into these deep repositories. Surface effects from seismic events tend to be have a much higher impact than if you're below grade. And George, I don't know if you found the same thing at WIPP, but that's what we found.
Yes, it's very similar. Yes, ma'am.
It sounds to me, from what you said, I think, what you just said, that the salt
very close. It's called a plastic property. It's more like a rubber band where you can pull it apart and it comes back. So it really doesn't have a fluid property, because the fluid property, if you had an earthquake, would tend to be stabilizing it as well. It maintains its structure, but it has a plastic quality and then it comes back. Good question. Okay. This slide is twofold. One, to illustrate the national cleanup that WIPP is responsible for, the true waste. There's approximately 22 sites we cleaned up, in particular Rocky Flats, but there are existing true waste sites. And one of the key points I wanted to point out here is that WIPP is located here, Los Alamos is here. We are a national program. We are essentially a customer to all of the sites across the nation. However, to be able to set the priority each year, that's established on a site-by-site basis based on communication and coordination between the federal entities. We have at least 2 times a year a corporate board meeting, which we manage this because these are all DOE or NNSA or EM sites with independent management. So we have to manage that true waste in a corporate manner. We have corporate board meetings where they come and talk about what are their issues, what are the lessons learned, what good things have been success, what are their priorities, are there settlement agreements, are there consent orders, how can WIPP facilitate that? At these corporate boards, we agree on a unified and consensus perspective of what sites get priority, what are the resources from characterization, what are our transportation resources, and the WIPP side. But we also got to look at budgets, because if you fund one site and don't fund WIPP, it ain't going to happen. Or vice versa, you fund WIPP and don't fund the site, you're not going to relate. So we look at that as well each year and plan for a 5-year planning window, which is a pretty long time in government planning when you get annual funding. So we really set the priorities year to year. So this is a national program that we're responsible for, but our focus is on the sites that are white, which are the current true waste sites that have stored true waste or generated true waste. So this is a national program. Next slide, please. To be able to manage a national program, you saw how widespread that was from coast to coast, essentially. We have a transportation system, which is, has very well trained drivers and a very good safety record to transport the waste site to site. Here's a quote from the National Academy of Sciences early on in WIPP's history about having a safer system than deployed for any other hazardous material in the U.S. This was just when we getting started. I'll show you some statistics in a bit how insightful that stage was. And it's not because of the National Academy of Sciences, it's because of the men and women who drive the trucks and the safe guidance we have in there. Next slide. Once again, the three legs of the stool I talked about: characterization, transportation, and disposal. Transportation is probably the most visible. A lot of the public sees that. It traverses the highways in New Mexico as well as the nation. We have a fleet. We're basically a trucking entity. According to the Land Withdrawal Act, the certification of the packages that we use to ship the waste in has to be certified by the Nuclear Regulatory Commission. DOE can't self-certify that. That's a requirement of the Land Withdrawal Act. That certification consists of a very rigorous program. We drop them from 30 feet to an unyielding surface. We burn them in jet fuel for 30 minutes, drop them on a puncture on a bar, and they have to prove leak tight even after that. So once they've achieved that, these packages, we get a certificate of compliance and are able to deploy. We have 4 basic packages. We have a True Pack 2, which is on the top left up here, which can hold equivalent of 14 55-gallon drums, 7-pack on the bottom and a 7-pack on the top. Each one of these packages is like a thermos bottle. It has a double container, two an inner and an outer item. So this is a True Pack 2. We have 84 True Pack 2s. True Pack 3, which is a rectangular box here, which is primarily for large pieces of waste. If you have a large piece of waste and you go to cut it up, you create 2 things: a potential risk to worker, and you create more waste. So if they can package it, put it in a standard large box, ship it to WIPP, we're able to replace it without a lot of work at the generator site. This is a very efficient package. We have 6 of those True Pack 3s. We have a half pack, which is half the size of a True Pack, and that is for efficiency. That will hold up to 7 55-gallon drums, and that's for weight. A lot of these waste and soils or gravels can be very heavy, so we don't have to have overweight permits, and we can efficiently transport the waste. Each one of these 3s is for contact handling waste. We have one shipping package for remote handling called the R872B, which inside here, it looks like Inside here is that canister I talked about 29 inches, about 10 foot long. It can hold up to 3 equivalent 55-gallon drums within it. We have 12 of these in our fleet. So we always have trucks either empties going up to these facilities and loaded coming back. So we have to look at this very closely in tracking satellites and the safety system. So, next slide.
Before you go,
Yes, ma'am.
describe for me how you team with the site you're packing waste from. Do you go in as a complete subcontractor and manage that, or do you have one WIPP guy, one NRC guy, and 10 guys from the lab getting that package together and certified? What's the ratio sort of like of labor? Who does what?
Let Dave and I kind of tag team that one, because there are 2 models that we have currently. We provide central characterization services to most of the sites, with the exception of Idaho, who has a lot of their own. So we send people to go to help with the certification and the characterization. They provide us the drum. The host site provides us the drum with the box on it, and we characterize it. We also have some officers to do the transportation certification for value for WIPP. And the WIPP driver driving to the WIPP site. The NRC is not there, because once they've given us our certification, it's our responsibility and license to manage that. If we have an inspection which is separate from the true waste characterization, we might have the environmental department or the EPA attend an audit or inspection of the characterization services. That's kind of and that's a different kind than we're actually characterizing waste, and they come in and evaluate the site to make sure they're following the requirements. So that's when we'll typically have a regulator show up for a true waste program.
So you use the word characterize in terms of packing?
In terms of
Specifically packing the stuff?
characterization is the process to ensure that the waste meets the requirements, which includes non-destructive assays, non-destructive examination like x-rays, visual examination, any kind of review of records. We're characterizing the waste that it meets the waste acceptance criteria so it can come to them. So a lot of the characterization all of it is performed at the generator site.
Okay, so it's the host who hires the locals or has the staff that does the physical packing?
So exactly right. So what we do is they provide the brains and we provide the brawn. So all of our, it's true statement. All of our folks that, the package itself, if it needs repackaging, it's non-compliant, which most of our waste is because they're not certified for containers. So we either overpack them if they don't have any prohibited items in the drum itself in a certified container, like the solid waste box, we just saw photos of it a little while ago. Or if it does have a prohibited item, then my folks would go in a containment tent in fresh air, in their NNMCAB outfit and triple gloves. They would open the container, and I always kind of joke that all the waste at Los Alamos is handcrafted. We don't have a lot of automation, so we would make it compliant. His central characterization program would watch us and sometimes do a visual certification, or what we call visual examination, to ensure we've repacked it to the waste acceptance criteria. Once we sealed up that container and released it from containment, his folks would do all the assaying as an independent group to say this certifies the WIPP waste acceptance criteria. My folks would provide the labor in getting it to and from their different assay equipment, and eventually we would work with them to develop a payload. And the payload would go into one of these true packs to be shipped. And what we try to do is be very efficient, and we've done a great job this year, is we try to maximize at least the volume, the weight, or the total activity any of those containers can have. So I refer to it as the pantry. We try and get a mix inside those shipment containers that we're getting as efficient load as possible, so we use less trucks. We don't have, in some cases, we actually have to put in a dunnage drum, which is an empty drum or empty container, to fill the space in the WIPP transport, because we don't want a handful of drums just inside. We have to fill each one of those transportation containers.
Okay, so I understand that you called it a picnic basket a few meetings ago. Now you're calling it a pantry.
Well, you go to the pantry, it's really a picnic
And
basket.
you optimize what's getting packed.
Right.
And then on the assaying that WIPP does, do you all do that on every single box or random credibility level?
on every container.
And we have, and CCP folks are audited by the state of New Mexico, by Secretary Ryan's office. The hazardous waste here, they have permit controls over them, and they audit all the facilities that ship with WIPP. And EPA also audits them and updates and looks at those on a daily basis. So it's a very regulated process.
Okay, I just want to thank you for clarifying how characterization dovetails into the packing process. That really helps me visualize and understand what's going on.
Thanks, Steve. Yes, sir.
Your jet fuel testing, have there ever been containers that have failed? Have there been any tests that have failed?
In the characterization process,
Yeah.
containers can be rejected if they don't meet the requirements. Yes, sir. Hold on, these packages, previous ones there?
Yeah, your jet fuel test.
Actually, they had, when they did the original test on, I believe it was the True Pack 3, for example, the first test, it did not pass on the drop test. We had a little bit of release the container. So they went back and reworked the closure on the door, on the inner lid of that, and then they tested again, dropped it again, and it passed. So there was an original minor failure on the True Pack 3, but the other ones, they have to pass so that we get the certificate of compliance. And what we do is we test a package, and then we have to build them all to that specification. So not each package is tested that way. It's just a testing program to get the certificate and make sure our construction, our manufacturing goes as consistent.
George, have you ever rejected any containers when they got to Carlsbad?
No, sir, not containers. We have had to overpack containers because we were concerned about some of the integrity. One of the regulations that we have to follow is the Department of Transportation has a certification for containers we call a Type 7A, which is an integrity test. So when we get containers out of the True Pack, for example, we look at them. If there's some concern with integrity, we can overpack, for example, a 55-gallon drum into a standard waste box. So we have done that early in about 2 years, probably 12 now, 2000, 2001. But the sites are very good about sending us containers that meet that certification. So it's not that those didn't need it, it's just early in our history we were very conservative in overpacking. So we haven't rejected any containers.
If one didn't meet your criteria, is it sent back?
No, sir. It depends. Likely we can overpack it, which means we would put that drum or into a standard waste box. If we had a standard waste box that wasn't compliant, we could put that into a 10-drum overpack. If it doesn't fit into one of our configurations, and depending on the nature of it, if we couldn't decontaminate it, we might consider shipping it back. We haven't done that. Good question. When I looked at this slide, I want to give you my assurance that the trucks of WIPP do not levitate. They reside on the road. My daughters, when we watch Disney, they would love this. They would think I'm right in tune with it. So I just want to give you that confidence. Nor is the United States floating either. The point of this slide is to emphasize that our trucks are monitored nationwide. We give access to states as well as Native Americans. Passport Protected website, and we're in constant communication with our central monitoring room at the website. We have people 24 hours monitoring empties going up and loads coming back. If there's a deviation, we get a notification, we notify the states, and try and get them back on route as quickly as possible. Yes, sir.
Why the 5-minute updates?
Predominantly for security purposes, but that's the frequency we've chosen as part of our tracking. Next slide. I wanted to emphasize a couple of the safety accolades. I could probably spend the next 3 hours talking about the history of WIPP and the multiple safety awards that it has, but I won't. So I will pick two here. One is what's called the Voluntary Protection Program, which has its basis with the Department of Labor from the Occupational Health Administration, which is a program that DOE encourages and recognizes safety and health of the contractors. This is a voluntary program, which means the employees, the labor force, the management, and the contractors have to volunteer to participate in that. If they do, we get to come in and audit independently, and it really is a collaboration of labor, the government, and the management to ensure that they are protecting human health and environment, and particularly the workers. DOE received its voluntary protection STAR status in 1994 and has maintained that. And the STAR status is the highest designation related to contract contractors who promote safety and health. That's something we're very proud of, particularly because it's a voluntary program participation, and it represents the workers wanting to be safe, and management supporting that, and government allowing that to happen. So that's an accolade for the workforce. The second is the transportation. In our 14 plus years of operations, we have more than 13.8 million safe loaded miles. Safe loaded miles. 13.8 million. That's tremendous. And that really is a testament of drivers and the criteria we have for them and their willingness to do drive safely. That is really a success. And that was one of the biggest concerns when we started was the transportation and the accidents. We've been very fortunate. That's a fantastic safety record, and it's to them, the men and women who drive those trucks and traverse the highways at all times of the year. Next slide. Talk a little bit about the shipment summary related to transportation. This is a bar graph that shows 1999, 2013, by calendar year, the number of shipments that we've had. To date, we've had over 11,600 true waste shipments. In 2013, this is calendar year, so we've got a couple more months of transportation. We're at 529. We will continue to increase and maximize what we can there. But in that year, we're able to support the framework agreement. We're able to support Idaho from the settlement agreement, Savannah River site, and Argonne. Those are the 4 sites that we're shipping from this fiscal year. Yes, sir.
What's the total number of cubic meters you could say?
I've got that in the next slide. You're a great person. If you could wait for that one, I'll wait. Just a couple points on this slide is 2007 is when RH True Waste started, our shipment started. So the first few years was CH Waste only. Since then, we've had CH and RH. Just to give you a perspective, our capability and our funding with our resources for this fiscal year is 17 CH shipments and 2 RH shipments a week. That's what we're funded at. Sometimes we can go past that periodically, but we can't sustain that. So that's what this funding profile represents.
What happened in 2008?
Good question. I wanted to kind of touch on it. I figured I'd get that all the time. 2008, there were 3 things that happened. We had a water line break at the facility. Remember, in 2008, WIPP was constructed and ready for shipments in 1988. This was ductile steel pipe in the underground, 20 plus years old. We had a break in it. We were down for several weeks at that time. We also had to take a standard waste box, which was in the underground, from a compliance order and ship it back to Los Alamos and get it repackaged because there was a non-conformance in there. We didn't think it was a violation, so we voluntarily did that. We got a compliance order. And to go in and take a standard waste box out of the underground and reverse that stuff took several weeks. We had that water line break. We also started what is called a long maintenance outage, which went for about 6 weeks. So we had those 3 main items that happened there that reduced the amount of shipments that particular year. So that was a tough year in the way of shipments, but it was a good year in the sense of recognizing the aging facility. One of the things that we have to do with is reinvest in that facility. It's 25 plus years old. We have salt, high corrosive environment. So a big part of our funding goes into maintenance, upkeep, reliability, replacement, and repair. So it's more of a plea for help than anything else.
What's the water used for in the facility? You have a big pipe, I think. You know, got the line. It was in the facility with the water line?
Yes, sir. We have 2 purposes. We have it for domestic. We have to have drinking water showers. We also have to fire water. We have fire water suppression in all of the buildings, and also the buildings where we have the staff house for the NNMCAB National Fire Protection Code protection.
Okay, but was the water line break below ground?
Yes, sir.
Down in the shafts?
No, sir. The shaft, actually the fire water loop goes around the facility, and we have close indicated valves. It's buried 7 to 9 feet. So that's where it burst, and that came up to the surface. It didn't go down into the facility. But I understand the perspective. Yes, sir. Yes, ma'am.
How long are your regular maintenance outages, and are they annual?
Yes, sir. We have had annual maintenance outages our entire history here. In 2008, we went from a couple weeks around Thanksgiving to maybe 2.5 weeks around Christmas, about 4 weeks, to a dedicated 6-week outage to address some of our aging facility to be sure we have that kind of things. So each year, since 2008, we've had a dedicated 6-week outage that oftentimes was stretched to a 7th week We also may have a mini outage on the weekend to be able to address fixes.
So they're 6 weeks standard?
Yes, ma'am.
Okay.
So we have approximately
Combined.
52, take away 6. Can you do the math? 56? 44, 46. There we go. 46 shippable weeks. We also have other items. We have holidays that we don't ship on. So as you take holidays from holidays and from outage, we have about 44 shippable weeks. That's a nominal time frame we put in our planning purposes. We have weather that comes up and we won't ship when there's ice or wind or certain things on our route, so we'll have to hold off shipments. Typically, Idaho in the winter is a difficult one. Sometimes Lamo, but not very often. We do have some weather-related items, and we will either stop shipments or delay them and then reschedule them.
How many shipments is WIPP able to accept per week?
Could you please repeat that?
How many shipments per week can WIPP accept?
Currently, this fiscal year, we're funded at 17 CH and 2 RH. Total of 19 shipments per week is what we're funded at.
And Atlanta was taking typically at least 4 of those a week, and this last month of the fiscal year, we're upping to 5, so we're taking almost a third of the shipments as a priority for 3706.
And we work collaboratively to ensure that they have the resources to be sure that they support those shipments. Just a couple other points. The big increase here in 2009 through 2011 was the Recovery Act. The sites got funding, we got funding. We had a lot of more funds and resources. Currently, we're at 4 sites. At that time, we were up to as many 8 sites. A lot of small quantity sites. The sites had money, we had more money, and we could maximize our resources. And you can see as the Recovery Act tailed down, funding went down. We were in continuing resolution. Our funding went down. Our throughput is typically tied to that. There's other factors, but that's a major item. Next slide will get us to this question. This is disposal summary. Another bar graph, look again from 1999 through 2013 by calendar year. Disposal summary. Up here on the top left, the true waste container volume disposed to date is 88,642 cubic meters. That's the container volume. I mentioned earlier that the Land Withdrawal Act, the Congress set our limit at 176,000 cubic meters. We're just about 50% of that capacity from our legislative limit item there. Once again, you can see the curve represents the increase. A lot of this waste here, the sites, let me just, going back to some of this curve here, when we first opened, people didn't believe it. They thought we were going to get shut down, we're going to regulatory. We went up, we had a manager come in SBI. She was very focused on this, and she helped drive this program very much in the shipments. Shipments increased, site recognized we were going to be there. We cleaned up Rocky Flats. A lot of the easy waste, waste that could easily be characterized, didn't have to be repackaged, as Mr. Bishop talked about, came through that. In 2006, we started RH, and we had a balance item. We also got a lot of easy waste tailed off, and Recovery Act came on, and now we're showing the reflection of disposal throughput. That's down, but one of the items that's up is the curies. The amount of curies, the radioactivity is actually increasing compared to some of the early waste. It didn't have a lot of curies in it. So from a real risk perspective, that is really the benefit of that. I don't have a chart. I'm getting one made that shows the curies, and it's on the upper side now, which is a good balance to have, because we often get the question, well, you're way down, how can you be successful? Because we're cleaning up the curies more than we have in the past. So, next slide. This is a more colorful picture of the underground, and I'm a little bit colorblind, but hopefully I'll be able to go through these and give a perspective of where we're at. Talked about the disposal summary on the amount of true waste in there, and where we're at from an operational perspective. Panels 1, 2, 3, 4, and 5 have been filled, and at least have temporary closures in them. We're currently in panel 6. We're actually in room 2 of panel 6 and placing contact handled waste. And we're in room 1, panel 6, with RH waste. Panel 7 has been mined, it's been certified by a professional engineer, and MD's inspected it and approved it. We will likely start RH replacement in panel 7 later this week or next week. We will now start in room 7. So in a given panel, RH goes into a room first, room 7, into the walls. Once that's that's complete, or actually what happens, CH comes through quicker, because we have 17 shipments and only 2. When CH comes in, it'll push us into the next room in RH. We'll move into room 6 for RH, and we'll start with CH and room 7. At the same time, we're drilling boreholes in room 5. So there is a bit of a lot of activity underground in a very small space, and we have to choreograph that, follow safety, conduct of operations, very much so.
This looks like a little more than 50% full.
Yes, sir, in the volume.
Yeah. I think that the CAB's a little concerned with the capacity that WIPP can have.
Yes, sir.
It seems that the Blue Ribbon Commission wants to move waste there. Hanford wants to move waste there. They have a certification, modification, I guess you question the Environment Department to allow Hanford liquid waste to go there. Greater than Class C wants to go there. It seems like WIPP is the answer to DOE's complex. It's concerning to us that does WIPP have the capacity, or will they have the capacity to entertain the rest of the waste that's left up there other than 3706, other than the framework agreement, whatever's left below ground, whatever's left at land, can WIPP hold?
Let me answer the latter part, and then I'll go through each one of those other 3 items that you mentioned and give you a response to that, if that's okay.
Thank you.
You bet you. And I recognize your concern, and I appreciate that. We have the same concern. Our priority, as determined each at the corporate board, is by site. We focus on LAML. LAML is our priority. We're there to meet the 3706 and exceed that if possible. We're also there to have the capacity for the additional below ground waste as well. One of the things that we do at WIPP is annually we collect data on the inventory at every generator site. And it's a pretty intense questionnaire, and the sites give us their data on what their estimates are, their best estimates of the stored waste and the projected waste that would be produced from the new generation, so we get a total amount of waste. Our inventory report, which the last one was 2012, LAML had about 9,880 cubic meters. 9,880 cubic meters. We're only halfway full, and we have 88,000. So we have, capacity-wise, we have capacity for LAML. Now, we will manage and look at all the site's needs, but based on the priority, our focus is LAML. That's where I give you my commitment, that our goal is to take every cubic meter of LAML and replace it at the weight. Now, we have 8 panels. I want to mention that the design is 10 panels. That's not a limit. The limit is the capacity. So if we don't reach that capacity, we can mine additional area. So we can have real estate there from a real estate perspective. From capacity, that's the question. So my commitment is that we will commit to that.
Is there any, at this point, conversations being had in terms of expansion for WIPP yet?
No, sir. Our true waste, the Land Withdrawal Act, limits us on our capacity, and that is our true waste mission is to fence generated transuranic waste at that 176,000 cubic meters. That is my mission. That's what I'm focused on. Now, there are discussions outside of the Department of Energy about WIPP. Now, the reason that is, I believe, is because WIPP is a very successful project. I believe because of its success, it's being looked at for many reasons. But to change the mission requires Congress acts, regulatory changes, agency procedures and requirements, years of changes that would have, obviously, in my opinion, maybe change the outcome, maybe change the volume. So I'm predicting way ahead of myself. The Blue Ribbon Commission actually did not say WIPP was a nuclear fuel. What they said was that WIPP is a good model of a repository, how it works, not as a candidate for spent nuclear fuel. So it's for a model of how a repository could operate.
Yes. You said you were about half full, but on the panels that are there, it's somewhat more than 5/8 full. So, do you need some kind of special regulatory actions in order to expand or drill additional panels, or can you just go ahead and do that until you reach that capacity of 176,000?
Good question. The answer to that is yes, sir. We need to have regulatory approval. And currently we have 2 proposals in. I mentioned previously that panels 9 and 10 are going to be in the drift area. We have a permit modification request in the New Mexico Environment Department to put panels 9 and 10. It would look just like 4 and 5, but just to the south. And the reason we do that is because these drifts have been open for 30 years, and we're bolting them and we're keeping them up. But if we go and put waste in there, we can't do maintenance to clear that area. So from our experience, we want to move those panels to the end. So this is a reconfiguration, not new panels. It's a reconfiguration to move those panels to location. So it's a regulatory approval. We have pre-submittal meetings. We have public meetings. It goes through a regulatory process. It takes anywhere from 18 months to 2 years. We have that same request in the Environmental Protection Agency called the Plan Change Request. They take about 2 years. Before that, we have to do our analysis, geotechnical, safety analysis, to make sure we have the right documentation so the regulatory agencies can approve that. So while we're doing that now, if you look, we're mining panel 8, we're in panel 7, it takes about 30 months to fill a panel. We'll finish that, we'll have 8, we need to have 9 and 10, at least 2 to 3 years ahead of time so we can maximize our resources. So yes, sir, it is a very robust, very public process to just do what we are able to do legally with our volume. We're not limited on panels, we're limited on volume.
Okay, so the approval for your volume, for your panels, you can go 2 more panels or 4 more panels? And what you're approved for right now?
What we have in our authorization basis is 10 panels.
10 panels, okay.
Yes, sir. When we submitted our permit back in 1991, the plan back then was 10 panels.
Okay, so that's what Congress has approved at this point?
No, sir, Congress is not. The only thing Congress approved is the volume limit.
Okay.
What we put in our permit that we can change is the number of panels.
Okay. Some panels can go to the north of 1 and 8, right? You probably put 2 more panels there? 2 more panels on each side of those corridors?
There are many options. Yes, sir.
And then you've got if you chose to, you've already got the north experimental area that you can use to store waste also, right?
Yeah. One of the things, if you notice this area kind of around the shaft, in mining there's a term called the shaft pillar area. You want to have the extraction ratio no greater than about 14%. You don't want to put panels in that area. But the land of drawback withdrew 4 square miles. This takes up about a mile. We have a lot of area if we ever get the authorization to continue to grow.
Also, if you went to 2 extra panels, 9 and 10 on the south side, was there any thought about using the central corridors, those 3 corridors going right down the center of those panels
Right down there?
to store?
Yes, sir. That was the original plan. Is what we would do is fill up panels 1 through 4, 5 through 8, and then start putting waste in each one of these drifts as we back out. But the drifts are very narrow because of our haul equipment. That remote handled piece of equipment that I showed you, we have to widen the drift to 33 feet. When you do that in the underground and you have the other open area, it transfers the stresses. So that area wants to creep in very fast. It creates a very hazard area. So instead of opening those areas, those 3 areas that you mentioned in the middle, and creating a safety concern, from a geotechnical, we want to move them just to the other area to protect us so we can extend the life with maybe another 15 years.
Okay, so there's plenty of storage space down there at what you're approved for right now.
Yes, sir. That's it. But volume and capacity. And each year, we'll sit with LANO and all the sites and establish the priorities. And our priority is LANO. Good question. Thank you all very much. Appreciate that. This is what I revel with, is the opportunity to show this particular slide because that draws so many great questions. Thank you all. Those were the main points I wanted to talk about here. Any other questions? Yes, there are a couple.
Yeah. One of the things that's come up is the question about accepting waste from Hanford. And Hanford has a lot of waste currently that's forbidden, period, from taking it. But there's been very little information on how much of that incredible volume of waste at Hanford would actually qualify as true waste that could go to the river. Can you enlighten us at all on what we're talking about there?
I have a little bit of information, and when I don't have any more, I'll stop. But, have looked at that a little bit. Many of the tanks that are in Hanford were actually carried in our inventory analysis back in 2004. And each year we get data from the sites. We're limited on that. The thing that will happen at Hanford is they'll have to go to a record, DOE will have to make a record of decision and decide what they'll be going to do with those tanks. They'll have to make a determination if they're defense, they have to make a determination if they're transuranic waste, and if they meet those two criteria, then they'll be likely to come to WIPP. Some of that waste may fall out as low level, may fall out as high level waste. I really don't know that. That's the process that they're going through and determining as an agency, as an entity, how to handle that. So what we would do, and every year, we would evaluate the inventory and match up that with the need from the individual sites and determine which site will get the priority. Hanford is at least 2 years out for even some of their current waste, not the tank waste, to go back to Hanford. So I see that out for several years at the earliest, given the way things are going in Hanford. But that is an EM site. That's an item we would have to evaluate as a corporate entity and make some very informed decisions. So your input is very valuable to us because we can take that into our deliberations, work with Mr. Bishop and Lano, and have that as part of our data in our decisions on the priorities each year. Yes, sir.
I didn't hear fully Steve's question, but are you considering greater than Class C waste also at WIPP at the present time?
There is an environmental impact statement that has looked at several alternatives for greater than Class C. One of the alternatives is WIPP. There has been no final decision yet on that item. And there's going to be a report to Congress and then a final decision on that, and I don't know what the final disposition is. Greater than Class C, to come to WIPP, according to our Land Control Act, has to meet those two criteria. Defense, is it transuranic? If it doesn't, the way we're structured from Congress would not cover it. But it's an alternative. Remember, an alternative may have to have some other changes to make it viable. And there's several alternatives and different configurations. If you look at the documentation, rooms all over the place that are alternatives, and we don't have a decision yet as an agency. As soon as we get that, I can probably better answer that question. Now, all of these EISs, like on the Hanford and greater than Class C, are all managed out of headquarters. And those are the folks who really have the answers or can provide you better answers and more informed than myself. I'm a sort of an intuitive or a inquisitive, curious George because of the WIPs. I like to get a little bit of information, but I know my limits, and I've reached my limit of greater than Class C and Hanford takeaways. But those are great questions, and I think that answered your questions, Mr. Chairman, on Hanford, greater than Class C, and the Ruling Commission. I tried to touch on all three of those elements as well. And if I need to address those more, please let me know.
Yeah, it kind of does. I mean, Hanford, if you say, is years out before we even entertain tanks. I know Savannah River's chomping at the best wanting to move where as fast as they can to WIPP. We're just concerned that looking at these panels that are filled up already and looking at the horizon of all of these agencies around the country wanting to push as much as they can into WIPP, that there is going to be capacity available through the next 5 to 10 years for the land.
My commitment, we fully believe that. I see them, I'm excited that they look at WIPP, but it's our responsibility to manage that in a way. And since we stewards in New Mexico, particularly myself, I grew up in New Mexico, I believe the priority ought to be in New Mexico and focus on the land side. And that's where we're at. We work very well with the New Mexico Environment Department, LANO, with you all. And that is the current goal and our commitment to continue to work that as a priority. So and each year we'll continue to revisit that and make sure we can address those items. Lee, did you want to say something?
Yeah, I did a little back envelope. I had my folks pull the current inventories above and below grade, and according to my folks this week, we have about 4,544 cubic meters left, which is a little less than 6% of the existing capacity. So all the retrievable CH and RH waste that we had would be a little less than 6% of the existing capacity at WIPP right now. That helps put things in perspective. Now, that certainly does not include the newly generated from NNSA, from ongoing programs, and it doesn't compensate for what the actual volume is after repackaging. And I think a lot of you have heard me state that drums multiply, that when we repack drums, we may have 5 or 6, one drum may become 5 or 6 because of the curie content, the total activity in the drum. And then we certainly found with the 3706 project that boxes reduce. We actually, in a lot of cases, when we place those boxes, we are using 10 nanocuries per gram. What's the definition of true? Since then, especially with the underground waste, they've changed the definition to 100 nanocuries per gram. So when we retrieve these boxes, whether they're from domes or eventually from the underground, they may or may not be transuranic. We've had a huge success rate this year with reevaluating those boxes and declaring low-level waste and using the commercial facilities, including the Neve Andrews facility in Texas. And also we've had a huge success with kind of using the Rocky Flats model, decontaminating those large items in the boxes to low level, so we have a very small volume of true waste, a little more concentrated, going to the WIPP facility, taking advantage of that real estate, not using it up inappropriately. And so we separate the transuranic component as we can, decontamination, into one single drum. So you may have a very large box. It turns out to be one single drum of transuranic waste, and then the balance of that waste is low level, and that will go to a commercial facility. So the numbers I gave you are based on current volumes. Just realize those current volumes adjust as we process and create WIPP compliant waste.
Does that include the milk?
Yes.
And every year we get data from them, make sure we get the right estimate inventory so we can adjust our plans, our workout plans, to support his needs, our allowance needs, the allowance needs. Next slide. Let's listen.
I know our time's beginning to run short, so I just want to get this question in before we wrap up. And I know we could go in a lot of different directions on this, but I am extremely fascinated with this corporate board that is able to mitigate between 22 different sites. And it's lovely to hear that right now NAML is a priority, and I'm sure that someone bylaws, it's a data-driven decision that y'all have rules and regs for how you prioritize. But can you tell me, A, about the makeup of this board, how often they meet, and B, if I'm, I don't know, Brookhaven or Missouri or someone that has been told, no, you can't send your stuff to WIPP this year, how do you queue up the ones that are lower priority?
Excellent question. They're actually, the corporate board is made up of the generator sites or storage sites that are currently shipping or that will be likely to ship in the future. So currently we have Oak Ridge, Lanos and Atlanta River, Argonne and Idaho as the shipping sites. Oak Ridge, Hanford is there, and other sites, small county sites would like to be there. They're federal and contractor composition. So all of those sites would attend a corporate board. They meet at least twice a year, and they establish the priorities. The other thing is it's a consensus group. It's exactly like here. You all have to agree as a unified entity that you're going to go over that. That's the same way we work. We've got to have a unified and consensus building. If we don't, we just continue to work at it. But we actually come out with good agreement and we work on those things. Typically, it's not so much, it is data, but it's compliance agreements, settlement agreements, other high priority risk items that come up there. So there's different criteria. But it's a very good, it's a corporate entity, and I believe my experience is we can respond. It works very well in looking at the National True Waste Program, which we're ultimately responsible for. Talking about priorities. Many of the things that previously talked about are identified here. Top priority is the framework agreement. We sit, and I say we because WIPP is very proud of what we're doing, as well as NANO is. Exceeded the goal by more than 100 meters, and WIPP is on track to meet the FY13 goal framework agreement, as we heard Mr. Bishop mention earlier, and even be ahead of that. The other priorities, Savannah Riverside, Idaho National Laboratory, and Argonne West. FY14 is coming up. We're also going to be looking at the same priorities with the framework agreement on top to meet the June 30th, 2014, or earlier if possible. We may look at Oak Ridge from a WIPP perspective to see if we can go there. They have some waste. If we get the right amount of funding, we might be able to do that. If we don't, this is going to be our priority. Next slide. I know we're running short. I'll just touch on two quick things. I'll talk about the regulatory agencies. The Environmental Protection Agency recertifies us. They look at the long-term disposal. Their time frame is 10,000 years. So we have to prove that WIPP is safe, according to their criteria, for 10,000 years. Their main emphasis is after we close the facility. They do look at, attend audits and inspections and do an annual inspection at the WIPP site. In the Mexico Environment Department, the Hazardous Waste Facility permit, they're primarily an operational perspective. We were in operation. We're responsible for the hazardous waste component, for groundwater discharge, for air emissions, for many of the record facility items, satellite accumulation areas, the containment, those kind of things at a record facility. The permit does have, after we close, a 30-year time frame for monitoring. So that's some of the biggest difference in the regulatory agencies. What I did mention, the Nuclear Regulatory Commission, the Department of Transportation, Mine Safety Health Administration. If you look at our regulatory arena, it looks a lot like the road back to Cleveland or Cincinnati. All the roads coming in, we have a lot of oversight, a lot of help. The NFSB, different side citizens. So, but that's good because we get a lot of transparency. It's a very, very outward and visible program. So I'm real proud of that, and these are some accolades that we have. We're regulatory moving forward, and yes, sir.
Just real quick question. The 10-year renewal, was that, that renewal, was it 10 years?
Yes,
by
sir.
NEMD?
Record regulation has this waste permit on for 10 years. Yes, sir. So we got that renewal in 2010, so it's good for another 10 years. We have to back up 180 days and submit an application of any changes before that so we don't get into that follow regulations. EPA is every 5 years. We've got to demonstrate continued compliance. And we're currently preparing an application to go in March 2014 with EPA to demonstrate we continue to comply with the long-term disposal regulations for the Environmental Protection Agency for the website. I think that's the last slide. Thank you very much. Any questions?
I've got one last question,
Yes, sir.
and that is WIPP campaigning either secretly or silently to receive Yucca Mountain waste?
Our mission is defense related to transgenic waste. And that's with the visibility of the EPA, all the folks that do stuff, we're very visible and transparent. That's our focus.